This is the practice assessment for sections 6.5 to 6.8. So one of the things that we talked about were the other 4 trig functions. We had spent the first part of this unit talking just about sine and cosine. So in the second part of the unit, we introduced tangent, cotangent, secant, and cosecant graphs. Now we're not going to graph those 4. The only ones you'll graph are sine and cosine. But that doesn't mean we won't write a tangent, cotangent, secant, or cosecant equation or extrapolate information from an equation. One of the things I want you to remember is that tangent and cotangent were the only 2 trig functions whose period was 1 pi. And so when we're finding the period of a tangent or cotangent equation, we used 1 pi over k. The other 4, sine, cosine, secant, and cosecant, all used 2 pi over k because the period of all 4 of them was 2 pi. So in problem number 1, it says write an equation of the sine function with amplitude 2, period 5 pi, phase shift negative pi over 2, and vertical shift 3. So other than memorizing that tangent and cotangent is 1 pi over k and all the rest of them are 2 pi over k, you also need to know the general equation for all trig functions. This is the general equation we're going to use. Y equals a sine k theta minus c plus h. What trig function goes here depends on the trig function we're telling you to write, and we'll tell you which one to write. The other thing is that only sine and cosine have amplitude, because amplitude defines a maximum and minimum value on the graph. All the other 4 trig functions don't have amplitude because when we graph them, the graphs went up and down forever. So when we go plug information into this equation, we're going to start with the 2 pieces of information that require no work. And those 2 pieces are amplitude and vertical shift. So let's get rid of amplitude, and in its place we're going to put plus or minus 2. Remember, we put plus or minus in front of the amplitude because we don't know what the graph looks like. The graph could look like this, or it could look like this. All right, next we're going to plug in the vertical shift, so I'm going to erase h, and in its place we're going to put 3. So now we have k and c left, and those require a little bit of work. There's an order in which you find this. The first thing you have to find is k, because k is going to come from the period formula. So because this is sine, we're going to use 2 pi over k, and we're going to set it equal to the period, which is 5 pi over 1. So now I have a proportion, so we're going to cross multiply. I get 5 pi k is equal to 2 pi. I divide both sides by 5 pi, and k is 2 over 5. So now I'm going to erase k, and in its place I'm going to put 2 over 5. Now I can go find c, and the formula we use to find c is c over k is equal to the phase shift. And the reason we have to find k first is because right now that equation has 2 variables in it. And you can't solve an equation with 2 variables, so you needed to know one of them. And luckily we know what k is, so I'm going to replace k with 2/5, and again, it's just a proportion, so 2c is equal to negative 2 pi over 5. And the last step is to divide by 2, but dividing is the same as multiplying by the reciprocal, and the reciprocal of 2 is 1/2. So c is negative 2 pi over 10, which reduces to negative pi over 5. When I go plug that into the equation for c, I get minus a negative, which becomes a positive pi over 5. And that's the equation. Let's do it again, but in number 2, we're going to write a tangent function with a period of 3 pi, a phase shift of 1 pi, and a vertical shift of negative 2. Tangent doesn't have amplitude, so we're just going to use tangent k theta minus c plus h. We're going to start the problem off by plugging in the vertical shift because I don't have to do any work to do that. It's okay if you write plus a -2 or if you change that to -2. Now we're going to find k. The period for tangent is pi over k, and we're going to set that equal to the period, which is 3 pi over 1. Now I have a proportion, so let's cross multiply. 3 pi k is equal to 1 pi. I divide both sides by 3 pi, and I'm left with k is equal to 1/3. So now I'm going to get rid of k and replace it with 1/3. The only thing I have left to find is c, and again we've set c over k equal to the phase shift. But you had to find k first, so we're going to replace k with 1/3 and solve that proportion. So c is equal to pi over 3. And now I'm going to replace c with pi over 3. And there's my equation. So now, what if I want to go the other direction? What if I give you an equation and I want to find the amplitude, period, phase shift, and vertical shift? I want you to start by finding the two pieces of information that require no work. The amplitude is 3/2. And in this particular problem, the vertical shift is 0 because there's no number being added at the end of the equation. Now let's go find the things that require work. To find the period, we're going to use 2 pi over k. Well, in this case, k is 2, and 2 pi divided by 2 is 1 pi. To find the phase shift, you set what's inside the parentheses equal to 0, and you solve that equation for x. So 2x is equal to pi over 4. And then you divide by 2, but dividing by 2 is the same as multiplying by 1/2. So we find out that the phase shift is pi over 8. Remember, if the phase shift is positive, that means the graph gets shifted to the right. And if the phase shift is negative, it gets shifted to the left. Number 4, state the period, phase shift, and vertical shift for y equals tangent 3x minus pi minus 2. Remember, tangent doesn't have amplitude, which is why we don't have one. So the first thing we're going to find is the vertical shift, which is -2. Now we'll do some work to find the other things. So the period, remember, for tangent, it's pi over k, where k is 3, so it's pi over 3. And the phase shift is what you get when you set what's inside the parentheses equal to 0, and you solve for x. So you add pi, and then divide by 3. So the phase shift is pi over 3. In problem number 5, it says write the equation for the inverse of y equals arc cosine x minus 5. We don't really like arc cosine because we're more familiar with this as inverse cosine. Well, how do you find the inverse equation for any function? The first thing we do is we switch x and y, and then we're going to solve that new equation for y. So you have to think about order of operations. What has to go away first? Well, the first thing that has to go away is inverse cosine. Well, what's the inverse of inverse cosine? It's cosine. We're almost done solving for y. The last thing I need to do is add 5. So the equation of the inverse is cosine x plus 5. Number 6, evaluate tangent of 1/2 inverse cosine of 0. I would do this in degree mode because I think it's going to help you out. Now, if you just plug this into your calculator, you're going to get an answer, but be careful. Sometimes you get a decimal and you need to figure out what the exact answer is. So I would actually do this problem in parts. Order of operations says to figure out what the inverse cosine of 0 is first. The inverse cosine of 0 is 90. And then you have to finish doing the operations in the parentheses. So 1/2 times 90 is 45. And if you do the hand trick, the tangent of 45, you bring this finger in, and then you flip your hand over. So when you flip your hand over, you don't see the 2, and the answer is square root of 2 over the square root of 2, which is 1. Problem number 7, the equation d equals 2.7 sine of 0.5 m minus 1.4 plus 12.1 models the amount of daylight in Cincinnati, Ohio for any given day. In this equation, m equals 1 is going to represent the middle of January, m equals 2 represents the middle of February, and so on. So what's the least amount of daylight in Cincinnati? Well, that's the same thing as saying what's the minimum. If you think about how you would graph this, the way we would graph it is you would start by graphing the midline, which is going to be at 12.7. Remember, the midline is the line that the graph oscillates about. Well, how much does it oscillate about it? Well, it oscillates the amplitude, so it goes up 2.7 and it goes down 2.7. So the maximum is going to be the vertical shift plus the amplitude. Oops, try that again. Minus the amplitude. So 12.1 minus 2.7 is going to be 9.4 hours. So that's going to be the minimum amount of daylight. The most amount of sunlight is the same thing as asking for the maximum, and we're going to find the maximum by doing the midline plus the amplitude. And 12.1 plus 2.7 is 14.8 hours. In part C, find the number of days of sunlight in the middle of October. Well, we can't find the number of days of sunlight because every day has to have sunlight. So this problem is probably asking you for the number of hours, which is what we're going to get from the equation. Now, if you changed your calculator to be in degree mode for problem number 6, your calculator needs to be in radian mode for this problem. Anytime you evaluate a trig equation in your calculator by plugging a number in, you need to be in radian mode. So, in order to find the number of hours of sunlight in the middle of October, we're going to plug in 10 for m. And 2.7 sine of 0.5 times 10 minus 1.4 plus 12.1 is going to give you approximately, oops, not 11, 10.9 hours. Now, if you had been in degree mode, you would have gotten 12 point something. Anytime there are approximately 12 hours of sunlight, that means there are 12 hours of darkness. That's an equinox. The equinoxes occur in September and March. So it wouldn't happen in October, so that's how I know that I would be in the wrong mode. Number 8. Let's graph y equals 3 sine theta minus 3. In our last half of the unit, we talked about graphing sine and cosine functions, and we changed their period and amplitude. In this particular part of the unit, we're still changing the period and amplitude, but now we're also changing the vertical shift and the phase shift. So when you go graph a trig equation, the first thing I want you to look for is the vertical shift. The graph gets shifted down 3. Well, that's where my midline is going to be. There's my middle of my graph, the line that goes to the middle of my graph. The amplitude is 3. That means the graph goes a maximum of 3 units above the midline, which is going to be at 0, and 3 units below the midline. That's going to be your minimum at -6. The graph is going to fluctuate between those 2 blue lines. Well, now I need to figure out the period. Remember, the period is 2 pi over k, and in this particular case, k is 1, because that's the number in front of theta. So if the period is 2 pi, and there's no phase shift, because there are no parentheses, the graph's going to start at 0, it's going to end at 2 pi. In the middle is going to be 1 pi. In between 0 and 1 pi is pi over 2. And in between pi and pi over 2 is 3 pi over 2. The graph is a sine graph, so sine graphs start its period on the midline. And because the amplitude is positive, it's going to go maximum, midline, minimum, midline. Remember that we always graph 5 dots, and they correspond with 5 tick marks on the x-axis. Let's do one more graph that includes a vertical shift and a phase shift. Let's graph y equals 2 cosine theta minus pi plus 2. So the first thing we're going to do is look for the vertical shift, which is 2. So I'm going to put the midline at 2. The graph fluctuates 2 units above and below the midline because that's the amplitude. So it goes up to 4 and down to 0. By the way, it does not always have a max or minute 0. That just so happens to be what happened in these two particular problems. The next thing we're going to do is we're going to find the period. The period is 2 pi over k, but in this case, k is 1, so the period is 2 pi. And the phase shift is what you get when you take what's inside the parentheses and set it equal to 0. Solve for theta. The phase shift is pi. So for my 5 tick marks, we have an interval on which we're going to graph this. And the way the interval works is it starts at the phase shift, and it's going to end at the phase shift plus the period. So the phase shift is pi, so we're going to start at 1 pi, and we're going to end at 1 pi plus 2 pi, which is 3 pi, because that's the phase shift plus the period. So on the x-axis, notice that I put my first tick mark not on 0, because we're starting at 1 pi. And then we're going to end at 3 pi. So in the middle is 2 pi. Remember, you can find the tick mark in the middle by averaging the two numbers. So 1 plus 3 is 4, and 4 divided by 2 is 2. Here, 1 plus 2 is 3, 3 divided by 2 is 3 halves. This one, 2 plus 3 is 5, 5 divided by 2 is 5 halves. And there are your 5 tick marks. When I graph this, I'm going to start here and end here. I'm not going to start at the y-axis. It's a cosine function that's positive, so it starts at its maximum, and then it goes midline, minimum, midline, maximum. And there's one period of that cosine curve. And that's the practice assessment for 6.5 to 6.8.